A few weeks ago, we covered an Arduino-based tester for two types of DRAM. Move over and make room for the Retro Chip Tester Professional, which tests hundreds of different chips, although that comes at a cost. Hello and welcome back to Noel's Retro Lab. Today we're going to be looking at the Retro Chip Tester Professional, which lies in the opposite end of the spectrum from that Arduino DRAM tester we saw a while back. This one sports a huge list of supported retro chips, including some unexpected kinds too. But before we can review it, we need to build it, because it's sold just as a PCB. And when you order your Chip Tester Professional, you get this. You get two beautiful PCBs, and you get an Atmega microcontroller already soldered in. And that's a good thing, because for a lot of people, that will be enough to be put off by the project. This is by far the most difficult thing to solder, so it's great that it comes already soldered and I imagine tested. The rest of the things are all very straightforward through-hole components, but we don't have any of them. This is not a kit. This is just the PCBs and the microcontrollers. So first things first, we need to go and buy all the components. The Retro Chip Tester Professional comes with a very detailed and long bill of materials. There's nothing hugely expensive or exotic there, just lots and lots of components, so definitely plan for some time if you're going to order them separately. At the start of the bill of materials page, there's also a link to a pre-populated cart, so that can be really handy if you're going to order it from there. Keep in mind, there are a couple of items that are not in the cart, and make sure you read the warnings in the manual carefully, unlike some people I know. And finally, here they are, all the necessary components. I hope we don't start with this and I find that I'm missing some of them. I did my usual trick of printing the bill of materials, and then I was able to, for now, just check that I have each of them. So this is multiple pages of them. And so with this to the side, we're going to start soldering the components. We need to talk manuals right now. I admit I'm not usually a big manual reader, especially not ahead of time. But this is something else. The manual for the Retro Chip Tester Pro is amazing. 141 pages full of illustrations and pictures and everything you could possibly want to know about it. We'll get into more details later, but it starts out with a very detailed assembly section with pictures of the process, which is extremely useful, a suggested assembly order, and even some tips and things to watch out for along the way. Since I'm going to be putting multiple resistors at once, what I'm going to do is I'm going to put it in this PCB holder, and that will make it easier to put all the resistors with their legs through and then flip it and solder it all at once. For things like this, it's really handy to keep this interactive bill of material PCB Explorer thing. Right now I was looking for R75, our 220 ohm resistor. So you just click on it and it highlights the place on the PCB for you, which is really handy when you have this many components. After I got this far, I very proudly posted a picture of my progress so far. I know it's not much, but I was just happy to finally get started with this project that had been sitting on the back burner for so many months. It was then that 8-Bit Museum, the designer of this board, just looking at the picture, pointed out that I had bought the wrong ZIF socket. Whoops! And he was right, of course. The expected socket has a thin middle bar, so you can use both wide and narrow chips. He even warns that about in the manual, but I didn't notice until then. So I scrambled and I bought another socket online, but coming locally, so it arrived in just a few days, just to find out that it was the wrong kind again. Apparently it's not uncommon with these kind of sockets to have one picture online, but to receive something else. Great! I've placed a couple more orders, hopefully one of those will work, but in the meanwhile, I had a friend send me one of the correct model for sure. Hopefully it will get here in time for this video. But unfortunately, that wouldn't be the only problem I would have with components in this project. Let's do a quick montage and see how far I can get with the build. The next step is to program the firmware on the Atmega microcontroller, And for that, that's why we have those pins in there. That's the ISP, I think stands for In-System Programmer. And so we need a device that connects here and a computer, and it can transfer the firmware. Unfortunately, all of those are slightly different, so I had to buy one just for this one. So apparently this one, Diamex AVR. AVR is a type of microcontroller. This one fits right here, and then it has a USB connector for the laptop. And that's good. We have a power light in here, and it detected COM5. Programming the Atmega involves two different passes. The first one is called programming the fuses, which is some non-volatile state on the microprocessor, which determines how the chip will act. The RetroChip Tester Pro includes a script to do this pretty much automatically, just by answering a few questions, so that's quite convenient. However, one of the problems of relying on scripts like that is that sometimes things don't go quite right, and you just march on like I did here. Right off the bat, it tried confirming that communication with the microcontroller was working and reported an error, but I didn't even notice that. Even when it came time to actually program the fuses, I still thought it was working correctly. And while there are no big error messages printed, you can see that it still can verify the Atmega signature. So it should come as no big surprise that when I went ahead with the next pass, which is actually programming the firmware, it failed completely. At this point, I went ahead and learned how to use the program to interact with the microcontroller by hand, and I tried just reading the fuses back, but nothing. It looks like the microcontroller was totally dead. This is kind of a worst case scenario, and I was afraid I had bricked the microcontroller, and there was no way to recover from this without desoldering the microcontroller and putting a new one, which I'm definitely not looking forward to doing. So I got in touch with Stefan, the designer of the board, and he was extremely helpful with suggestions of things to check. It turns out a lot of those suggestions were already in the manual under the troubleshooting section towards the end. Remember I said I'm not a very big manual first person? Anyway, that included some on how to recover from a non-responding microcontroller, which is what we have here. Depending on the fuse configuration, the Atmega might be driven either by a clock signal or by the signal from an external crystal oscillator like the one we have here. If the wrong value was set on the fuse, the microcontroller might not be working at all because it expects a full clock signal. So in that case, we can try jump-starting it like if it was some kind of old car by providing a fake clock signal. So here comes Arduino to the rescue. This is a super simple program that simply generates a square wave signal on some of the output pins that we can use as a clock signal. To jumpstart the Atmega, we're going to jam it right on top of the oscillator signal and hope the microprocessor picks it up. I've already loaded the program here, so this should be active already. And we're going to drive specifically this pin right here. So because it's actually pretty snug, I've just put the connection right under the resistor, making contact in there, and then we can use any of those ports between 8 and 13. So I'll just grab that one. So now I'm gonna plug in the programmer, and let's see if we can program the fuses. There you go. It just did it. That's excellent. So actually that didn't work. That was an error message that we got in there. So let's try it again. Apparently this is normal because the clock signal is not perfect. So sometimes you just need to try it a few times. And now it really passed. Now we have a bunch of writing and reading, and it looks like it's verifying that those values are correct. So I think that worked now. And now with the Arduino disconnected and just the programmer, let's try flashing it. Now it's working. That's great. Okay, I think we may be done. This is a good time to mention that you can also buy the RetroChip Tester Pro already flashed with the correct firmware, which could save you some of this trouble. However, Stefan is constantly updating the firmware, adding new chips and improvements, so even if you get it flashed, you may want to learn how to do this procedure to keep up with improvements. And finally, the moment to test it for the first time. So I'm going to put the LCD screen in place, like that. Yeah, holds itself okay. Right now, I'm just going to power it with 9 volts in here, and I don't have the extra power board. That's whenever we want to start generating other kinds of voltages like +12 or -5. So I'm going to turn it on, and well, this turned on and this turned on, and I see on the power supply that we're drawing very, very little current. Although wait, you know what it is? I think I saw something like this in the manual. I think this adjustable resistor controls the contrast on the LCD, just like the LCD on that Amstrad PPC that tricked me once. Won't let me trick me again. There we go. Nice. So yeah, that's perfect like that. This is awesome. This means it's working. And here are all the components for the power board. This should be a lot easier after having done the full main board. And finally, the correct socket arrived. So here we are, finally ready for the first test. As soon as we turn it on, we get the starting menu, and then immediately we move on to the selection of the chip you want to test. Because this is not a tester for one type of memory or two types of memory like we saw last time with the Arduino tester. This tests hundreds and hundreds of different chips. So the way this works is a little counterintuitive to me. It's we'll talk about more about it later. But the idea is that the hundreds of chips this machine can test are all in a sequential list. So by pressing select, you move on to the very next chip in that list. So right now we're in the 2114 static RAM, and then if I press next, it moves to the 6550 static RAM. So if I wanted to go to some EEPROM that maybe was towards the end of the list, I would have to just press this a long time or just leave it pressed. However, it has also the jump button, which lets you jump to the next section in that list. So if I press jump, so it doesn't look like anything has changed, but apparently the 3101 is the beginning of the next section of the static RAM list. And I think if I press again, I go to the DRAM section. No, not yet. Okay, so this, as I said, is not the most intuitive thing in the world. So again, okay. So now we're in the DRAM section, and I don't know if I press it again, whether there will be multiple DRAM sections. In the manual, he has a very clear list with all the sections and all that. It almost feels that for this to be really effective, I should print that out and keep it next to the machine. Once you're within the section that you want, then you can press select and you can move on to the next one. So if I wanted to go to the 4164, which is a very common chip, here we're at 4116. So I imagine 4164. But right now, if I pressed OK, we could go ahead and test that. One of the things that is kind of crazy to me is that if I press select again to see maybe there's another option with this, oh, now we're at 4464. I want to go back to 4164. You can't. There's no back button as far as I know. There's not even a combination of these guys that will go back one. That to me is totally crazy. It feels like it would be so much more usable if I had another button to go back. By far, I think the ideal interface would be a rotary controller and an OK button. With a rotary controller, it lets you move back and forth really quickly, and I would make this sub-menus. So I would make SRAM, DRAM, whatever thing comes next. Those are the things you select in the top level. Once you press OK, you go in that level, and then with the rotary dial, you select the different models within that category. And if not, a back button would be awesome. So for the tests, I'm going to be coming here to my boxes of DRAM, SRAM, and these are the 74XX logic chips. We'll have lots of examples there. And then for something that is supposedly not working, we'll reach over into the box of shame that you've seen before. This is where all dead chips go. This is, I guess, the chip graveyard. So let's start with one of the most common DRAM chips, at least, the 4164. Those are the ones that we've tested before with the Arduino tester. One really nice thing about this tester, I believe, is that it doesn't power anything here until you press OK. You know what? Let's test it. I like testing things. So ideally, we should not be seeing 5 volts right here. Perfect. Yep. And then once we start the test, I'm sure all those transistors are driving the right power to the right pins. I'm going to press OK. And now it's testing it. And right away, we're getting feedback here, which is really good. I definitely like to see what it's doing. And this is not just a status bar feedback. It said check in 0. It was writing all zeros and reading all zeros. Now it's telling us that it's actually writing all ones and reading all ones. and now it's doing an alternating pattern, 0, 1, 0, 1. So we know it's alive, and we even know what it's trying to do. And when it fails, we'll know why it failed. So that's actually super cool to have more insight into the tests that are happening. It's even doing a random read-write test. And the blink rate of this slowed down a little bit, which tells me this is going to take a little longer. So those are actually the exact tests that I had in that source code that I wrote for a quick Arduino test, which makes sense. Just as a bare minimum, 0, 1, alternating ones and zeros, the other way around, and random. Okay, it makes a beeping noise, test passed, and asking us whether to do it again. So that's great. So instead of changing chip types right now, I'm actually going to give it a faulty 4164. Oh, there we go. So this one, I have it marked as faulty, but look at that. Right now, it's writing zeros and reading zeros okay. There you go. And now, oh, this must be address. So maybe at address 1000 hex, it returns a 1 instead of a 0. And that's not like it matters. I mean, we're going to throw this away no matter what. But the fact that this happens at address 1000 probably tells me that this is an addressing issue, and that is failing because that's the first time we set that bit to access a particular memory cell. So that's very interesting, the kind of information that it gives in there. So let's try a more interesting DRAM chip, which is the 4116. And this is more interesting because it needs not just 5 volts and ground, but it needs minus 5 volts and plus 12 volts. So this is where this power board is going to come in handy if it's working correctly. Well, I guess we're about to find out. Interesting, I heard the relay click. So obviously that's what those are for, to relay the minus 5 and plus 12 to the chip area. Perfect, it passed. And now let's give it a non-working 4116. I imagine this is going to go quick. Yeah, boom, okay. Very cool. You see, that is why it's good that the power is disconnected. I grabbed this chip, and as I grabbed it, I dropped it and put it like this. If it was powered, pretty much bad things would have happened. So I'm very glad this is powering up only at the time of the test. Let's try something different. This is probably the most exotic, or for me anyway, DRAM that I have in my box. This is listed as MCM, so Motorola 514256. I know this is a 256K times 4 bits. When you have a chip like this and you don't know exactly what option to select, you can use the interactive IC database provided with the documentation. We can type the markings on the chip, and it tells you what kind of chip it is and the specific name and section to use for the testing. That's super handy. And it brings us to the 44256, or the 256K times 4 bits. And let's test it. This is probably going to take longer, I imagine, because there are many more bits in there. Wow, that took several minutes, but hey, it passed, and that's not a dig against the tester. Really, I don't think you could go much faster than that with the amount of tests that it did on the 256K times 4 bits. That is not an insignificant amount of memory. The strength and the most unique thing about this tester is the kind of chips that it can test. So let's get a little bit more exotic. I'm gonna grab some of these static RAM. These are MCM 6810. These are static RAMs used on the TI-99 4A. So this is only 128 bytes. Well, that was very quick. That was only 128 bytes. So I expected that. And what about logic chips? We have lots to choose from. Let's start with some easy ones. So, hey, I was just using the 7408 AND gate. The tests for this should be instant. Yeah. Doesn't say anything. I guess it will say failed if it failed. I have a bunch of logic tests in here that are supposedly failing. So let's grab one of them. For example, here's a 74 HCU04, and wow, that's taking a long time. Okay, so it's interesting. With the logic chips, it's not printing success or failure. And I actually just realized why we're not seeing the results when we test a logic chip. Because I didn't follow directions properly and I got the wrong screen. This is supposed to be a 20 by 4 LCD or OLED screen. It's a 16 by 2, so no wonder things are getting cut off sometimes, and we're totally missing 2 lines. So I'm even shocked that we managed to get this far. And here's the right part. This is pretty obvious once I put them side by side that this is the correct one. And that also explains why this wasn't going all the way to the edge. I'm like, oh, that's kind of weird that there's that space. Well, yeah, because I chose the wrong screen. Okay, and there it is with the support. And I think it's really cool that the interface to both screens is identical, even though the screens are significantly different. I think it's just really cool that they're literally plug and play. Let's turn it on, and yeah, there you go. Look. Oh, interesting. So this is the information we were missing earlier. There was something saying mode most chips. So I imagine that's because we're only seeing a selection of the most commonly used chips, and we can change that to have all of the chips, but that's a lot of them. Also, it tells us that for the currently selected chip, it tells us where ground and VCC are. So that's an extra protection, so you can double check things. But anyway, let's go back and check our 7408. Perfect, so now it really says chip OK again. That's the bit we were missing. I wonder if we were missing much with the DRAM tests that I did. Let's do one really quick. Let's see how it works. Oh, there you go. We have a nice progress bar in there. That before we had that 0 there in telling you what kind of test it was doing, but then the bar tells you how far it is in that test. So that's a great feedback. Something that I wished for in the other DRAM tester. Excellent. Yeah, definitely use the correct screen size. It's also worth mentioning that the Retro Chip Tester Professional supports a huge variety of chips, much more than I've had the chance to show here. The manual lists the full table, and it includes things like FIFO RAMs, bipolar ROMs, PALs, and even some Soviet chips. And wait, it doesn't end there. You can define your own parameters for your own custom RAMs, and there are even adapters available to be able to hook up SIMs and many other devices, so it really works with a huge amount of formats. So finally, let's try a category of chips that we haven't tried yet, which is ROMs and EEPROMs. I'm going to try reading these Amstrad ROMs that I have right here. And interestingly, this comes preloaded with the knowledge of several common ROMs. I doubt this is one of them, but first of all, let's find out. So these are 16 kilobyte ROMs. I know that just because this is the floppy disk controller ROM on the Amstrad CPC 6128. And so because it's 16 kilobytes, I need to select the EEPROM equivalent of a 27C128. Oh, wow. Check it out. It is supported. It doesn't say that is the floppy disk drive one, but that's good enough. I mean, that's fantastic that it says that. So the next step is, well, wouldn't it be great? We just read it. Wouldn't it be great to actually get that data? We can't do it because this is not connected to anything, but we can connect it to an SD card module. And that's what we can use that for. And obviously I need an SD card. And so now pressing and holding the OK button tells you that we want to do a dump, not just a CRC. There we go. Saving, it gives us another progress bar. Okay, it tells us that it's created on the disk. And yeah, it tells us again that it's an Amstrad ROM. So that is super handy. And how much does the Retro Chip Tester Pro cost all in all? The PCBs on microcontroller are sold at cost, which come out to be around 36 euros plus shipping. The components, if you order them from the store with a pre-made card, come out to be around 40 euros, already including shipping. I have no doubt you can find them cheaper on places like AliExpress or eBay, but apart from the risks of getting incorrect or counterfeit parts, chances are you're going to spend close to the same amount of money. You'll just get many more spares for each part, which is not necessarily a bad thing. For the extra parts not in the cart, like the LCD and the zip socket, it's probably around €6. Just don't do it like me and make sure you get the right ones the first time. And finally, the USB ISP programmer was €23, although you could use the Arduino directly and save yourself some money. In any case, that brings up the total to about €110. So the big question is it worth it? There's no doubt that this is a very complete and very well designed device. My only real complaint about it is the user interface, but other than that, it's really, really good. The variety of chips, the feedback during the testing, the reporting of the errors, it's all really good. It also addresses head-on some of my other concerns about the other chip testers by providing a protection to the microcontroller from faulty chips and by not turning on the power until the test starts. It really is fantastic. However, all of that comes at a cost. The obvious cost is the price, because at €110, it's not exactly an impulse purchase. The hidden cost is the time and effort to assemble it. Ordering the parts, building it, testing it, flashing it, and if you're like me, ordering the correct parts again. It's all part of a fun, extended project, but don't underestimate the effort required. So in the end, is it worth it? If you only repair a few machines a year, or you mostly work on the same kind of machines, then it may be hard to justify getting this device. I personally do a lot of projects with a variety of machines, so I'll be constantly using it. So if you're like me, then it's a fantastic device, well worth the amount of effort to put it together. So that's it for today. I'm hoping to review other chip testers in the future, so stay tuned for those. I hope you enjoyed this episode, and as usual, let me know what you think in the comments, and I'll see you next time. If you enjoyed this video, please consider supporting Noel's RetroLab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.